Guys, yeah, welcome back to my channel. Today I want to quickly show those students out there who are preparing for JAMB the tips on how to identify elements lithium to calcium groups and their charges. It is very what simple. How do you identify the elements lithium to calcium? The more reason why I exclude hydrogen and helium is because hydrogen does not have a particular group it belongs to. Though I'll be dropping a video on why hydrogen does not belong to group 1, but majorly when you check the periodic table, it is being classified as group 1 elements. And the more reason why I'm not using helium, because many students out there are exposed to helium is group 2 elements. No, helium belongs to the inert gas, or we call them the noble gas. So guys, let's play with the lithium to calcium groups and see how we can easily identify their charges and the groups. So for example, lithium is our atomic number 1. So don't forget, I dropped a video on electronic configuration in my previous video, and that you can easily check that. So I'll be showing it here because I want you guys to know how to identify the groups and the period as well as the charges of each element. So now for lithium we have atomic number 3. So that goes to be what? 1s2 and 2s1. With this is what you have here. You have 2 comma, we have what? 1. And when you draw the shell, the inner one is the K shell. So which is this? We have 1, 2, and the 1 is what? 1 here. So I'm making use of these two to show you guys how we can easily have the group, the period, and the charge. And before we go deep into that, note one thing as a jambers out there. From group 1, 2, 3, and 4, they always have a positive sign. Again, group 1 to 4, they have a positive sign. And how do we determine the positive sign of each of those elements from group 1 to group 4? It is very simple. Are you with me now? Or is that clear with you? So guys, if a particular element has outer electron of 1, that kind of element belongs to group 1. Again, if an element has an outer electron 1, that element belongs to group 1, and the group 1 there shows that lithium has a positive 1. The outer electron of each element from group 1 to group 4, we tell that is the charge of that element. Is that clear now? So this is group 1. And how do we identify the period? Is that clear now? How do we identify the period? You will count the number of shell, just like what you have here now. We are having 1 here, which is something as what? Group 1. Here we are having what? 1 here as group 1. So when you count the number of shell you have there, we tell you the period. So let's count. 1, 2. So lithium belongs to period 2, group what? 1. So let's count the shell. 1, 2. Period what? Period 2. So now this is a clue. The number of shell determine the period, while the outer electron determine the group. Again, the number of shell determine the period, while the outer electron determine the what? The group. That is that for lithium. The next one, as you all know, after lithium is what? Beryllium, with atomic number 4. So I'll be picking either I should make use of this electronic configuration, or I should make use of that of the shell to determine the period and the group and the charge of each element. Don't forget, lithium has what? Positive 1. For this, we have 1s2 and 2s2. So this is equivalent to what? 2, to this, and what? This. So the outer electron here is 2. That gives us what? Beryllium is what? Plus 2. Because I told you guys earlier that from group 1 to 4, the outer electron determine the what? The charge of that element. And the outer electron here is what? 2 class. So these 2 here, the same thing represent the what? Group 2. Then we have what? Let's count how many period? 1, 2. We have what? A period 2. So let's take a look at this in this format now. We have 1, 2. The other one is what? 1, 2. So guys, the number of shell here is 1, 2, which will give us a what? The period. So let's quickly have it here. Number of shell equal to period. Outer electron equal to group from group 1 to 4. We have the formula from 5, 6, 7, and 8. So guys, I've picked 2 elements now. Lithium, we have a positive 1. Beryllium, we have a what? A positive 2. Are you with me now? So I'll be going with another element, which is what? Boron, atomic number 5. Carbon, atomic number what? 6. So guys, I'll quickly jump to sodium, magnesium, aluminium, because I'm only playing with what? The first element that deals with the group 1, group 2, group 3, and what? Group 4. So after this, I will move to group 5, group 6, group 7, and group 8. So here equal to what? 1s2, 2s2. So some students out there, because we're having boron to be 5, they will just assume that this 2s2 should be what? 2s3. No, because according to our Bohr principle, you must fill in the lower energy before you fill in the what? Higher energy. And s orbital can only contain just 2 electrons, from 1 to 2. Are you with me? While p can contain from 1, 2, 3, 4, 5 to 6. So this we have what? 2p1. So let's think about what we have 2 now. There's a formula. We have what? ns2 and what? np6. This govern our octets rule. So when we are going to add these 2s2 and 2p1, that will give us what? 3. So guys, the outer electron here, this is our what? Outer electron. And I said earlier that outer electron is equal to what? The group. That is, we are going to use the outer electron to determine the group and as well as the charge of that element. The outer electron is what? 3 class. So our boron belongs to group 3. So let's count the number of periods, the number of shells. So let's go 1, 2, period what? 2. So the charge of this is what? 3 plus. So why for carbon is equal to 1s2, 2s2, 2p what class? 2p2. So let's go. We have 2 plus 2 give us what? 4. So this is what? The outer electron. So we are having what? Plus 4. So the outer electron initially will tell us what? The group. So we can say carbon belongs to group 4. Period. Let's count 1, 2. Period 2. So let's quickly move to the elements that belongs to group 5. So you can say group 5 elements, group 5 to 8 elements. Are you with me, class? So this group 5 now, I'll pick phosphorus, atomic number 15. So let's go, class. We have 1s2, 2s2, 2p6, 3s2, and 3p what? 3. Are you with me now? Exactly. So now, don't forget I told you guys that the octet we are going to what? Add this together. So we have 2, 2 plus 6 will give us what? 8, what? 5. And when it comes to group 5 to 8, this is a formula. The group number minus 8 equal to the charge of that element. Again, the group number minus 8 equal to the charge of that element. So guys, now we can easily tell that phosphorus belongs to what? Group 5. But we are not going to add it to what? A positive 5, because I tell you guys that from group 1, 2, 3 and group 4 they have a positive sign with their outer electron determine the charge of that element. But reverse is the case from group 5 6, 7, 8. Their outer electron will be subtracted from 8, will tell us what the charge of that element. So I'm picking this now because we are starting with what? 5. So I'm going to relate this phosphorus with nitrogen because nitrogen has atomic number what? 7, which will give us 1s2, 2s2, and what? 2p3. And this one is equivalent to what? 2, what? 5. Now we are going to look at the charge of those elements now. So for this, the outer electron, the group number is what? 5. Which is the same thing as the outer electrons. We'll be having what? 5 minus 8. Is that clear? 5 minus 8 is equivalent to what class? Minus what? 3. The same thing applies to nitrogen. This is the outer electron, which represents the group number. So it means that phosphorus belongs to group 5, but the charge is what? 3 minus. Nitrogen belongs to group 5, but the charge is what? 3 minus. So with that, you can say this also will go with this. So we have what? Minus 3 for phosphorus. So the next one, silicon. Well, let's play with sulfur. Sulfur first. Sulfur give us what? Atomic number what? 16. So let's go class. We have 1s2, 2s2, 2p6, 3s2, and 3p what? Class 4. So let's go. You can say we have what? Class 2, and this 2, 8, 6. So now the same thing we did for here, I can pick elements oxygen, which is what? 8. So we go 1s2, 2s2, 2p what? 4. So class, you can say we have 2, what? 6. You can see that. So let's go back to this phosphorus. 1, 2, 3. We have period 3 for phosphorus, but group what? Group 5. But the number of charge here is what? Minus 3. The same thing is applies to this sulfur. 1, 2, 3, period 3, but the group number is what? 6. So nothing like plus 6. So please don't make that mistake as a jamba is out there. So you just said, according to this formula, like I said, 6 minus 8, we have what? Minus 2. So we have sulfur to be what? Minus 2. Because many students will be out there, how can I tell if one element is minus 1, minus 2? No, it is very what? Simple. Check on this video. So the same thing is applicable to what? That of the oxygen. So that is why your oxygen always have what? 2 minus. So the next one is chlorine. Atomic number 17. So 1s2, 2s2, 2p what? 2p6, 3s2, 3p5. Are you with me? So this one you can say we have what? 2, 8. 2 plus 5 is what? 7. So we can pick fluorine 9. Atomic number we have 1s2, 2s2, 2p6, 3s2, 3 so we stopped at, so I think so we stopped at 2p5. So these two will give us 2. This 2 plus 5 we have what? 7. So now guys, let's go. We can say 7, the group number is what? 7, period what? 3, minus 8 we have what? Minus 1. So the same thing is applicable to what? Fluorine. So that is why our chlorine, if you are a student that have been studying for a jam, what does have what? Minus 1. Why fluorine does have what? Minus 1. So guys, let me show you guys the last one, which is neon and argon. So argon, AR is what? 18. Neon is what? 10. So you can say we have 1s2, 2s2, 2p6, 3s2, 3p what? 6. This one we have 1s2, 2s2, 2p what? 6. So let's go class. This we have 2. This we have 8. This we have 8. This we have what? 2. This we have what? 8. So that's one. For argon, the outer electron is 8, which is what? Argon belongs to what? Group 8. When you look at the right hand side of the periodic table, are you with me now? At the the p orbital there, so we have group 8 there, or 0. Y for neon fall under the same thing. So let's see, why are they called group 0? This is a secret. The group number is what, class? 8 minus 8, we have what? 0. The same is applicable to what? Neon. That is the reason why, if as a student you have come across those first 20 elements, you observe vividly that your helium, your neon, and your argon does not have any charge. So guys, this is a tips of how you can easily identify the charge and groups of some elements. Though for those of you that are having issues with how to write out your electronic configuration, you can easily check in my video catalog and watch the video where I explain about principle, Ohm's rule, and relating it to what? Electronic configuration. So guys, don't forget to subscribe, like, and share among your colleagues.